Hi everyone, this is going to be your Algebra 3 Part 2 test review for your test that you will be taking tomorrow. We are going to review a few things that I have seen some issues on your past test, and then as well as just review some new concepts that will be touched on this test. The first thing that we're looking at is going to be finding the domain of a function. Now, I know we've been doing this for a while, but I do want to review what you are looking for. So I am going to be starting by looking to find the domain of this function here. F of x is equal to the square root of 2x plus 6 over 4x squared minus 4x minus 3. So what we want to do is there's two things that we're looking for when we're finding the domain, is that our square root has to be greater than or equal to 0, and that our denominator cannot be equal to 0. So those are the two things that we're worried about. And if we look at this equation here, we have both of those things. We have a square root and we have a denominator. So the first thing that we're going to do is we're going to worry about the square root. So I know that my square root has to be greater than or equal to 0. So everything inside of it, my 2x plus 6, has to be greater than or equal to 0. I'm going to start by solving for x. So I'm going to move the 6 to the other side, giving us 2x is greater than or equal to negative 6. And then I'm going to divide both sides by 2. Now I have x is greater than or equal to negative 3. So that's my first condition, is that x is going to be greater than or equal to negative 3. Now I have to look at the denominator, where 4x squared minus 4x minus 3 cannot be equal to 0. Now the only way I can find out how that won't be equal to 0 is by solving this equation for x. And that is going to be done by using the quadratic formula. So I have a, b, and c. I have x is not going to be equal to negative b plus or minus the square root b squared minus 4 times a times negative 3 all over 2 times a. So that's a little tricky to see. So it's b squared minus 4 times a times c. Now two negatives are going to make a positive, so that would be positive 4. Inside my square root, I have 16. And then I have 4 times 4 times 3. And that would be two negatives, so that would be plus 48 all over 8. Now if I add this together, that becomes a square root of 64, which comes out evenly, which means that x cannot be equal to 4 over 8 plus or minus 8 over 8. Now if I simplify that, 4 plus 8 would be 12 over 8. And 12 over 8 can be simplified by 4, so that would be 3 over 2. And then I have 4 minus 8 would be negative 4 over 8, which would be negative 1/2. So in addition to my x has to be greater than or equal to negative 3, I also cannot have x equal to these two terms. And the way you write your answer is this. You'll say x is going to be a real number, but x has to be greater than or equal to negative 3, and x cannot be equal to 3 over 2 and negative 1 over 2. And that would be your domain. Now I want you to practice this problem. So you are going to do problem set 34, number 17 as your practice problem. So the next problem we're going to look at is inverse functions, and this is something that we didn't really talk about on your last test, and it was supposed to be covered on that test. But inverse functions. So the property of an inverse function, remember, is that in lesson 40 is where we talked about inverse functions. And what you are going to do is you are going to, sorry, this is supposed to be problem set 34, number 22, not number 17. So problem set 34, number 22 is actually what you're doing. Now what we're looking at is the inverse functions. So I'm going to do the example on page 290. And what that gives me is that f of x is equal to 1 over x minus 3, and g of x is equal to 3x plus 1 over x. Now, in order for us to see if these are inverse functions, what you're going to do is you have to evaluate their composites. Now, if both of their composites are equal to x, then you know that they are inverse functions. If they don't equal x, then they would not be inverse functions. So I'm going to start by doing f composite g of x, meaning that I am going to plug my g function, my 3x plus 1 over x, into my f function. So wherever I see an x in my f function, I'm replacing it with this entire function. And that would become 1 over 3x plus 1 over x minus 3. Now I want to make a common denominator here, so I'm going to multiply this by x. Remember that this is a negative 3, so this would become 1 over 3x plus 1 and then minus 3x all over x. But what you should see there is my 3x's are actually going to cancel. Now I have 1 over x, and to get rid of the complex fraction, you're going to multiply by this reciprocal, and therefore this is going to be equal to x. Because that first one is equal to x, now you have to go and do g composite f of x. And we know what my f function is equal to. It's equal to 1 over x minus 3. Which means wherever I see an x in my g function, I'm replacing it with this 1 over x minus 3. So this would become 3 times 1 over x minus 3 plus 1 over 1 over x minus 3. Now in order to add this to the 1, I have to make a common denominator of x minus 3. My denominator is going to stay the same, but my numerator is going to become 3 plus x minus 3 over x minus 3. That's all going to be over 1 over x minus 3. So what I should see in this numerator is that the 3 and the negative 3 cancel. And then to get rid of the complex fraction, I would multiply top and bottom by the reciprocal. This would cancel, and I am left with x. So since both of my composites are equal to x, my answer is going to be yes, they are inverse functions. And the practice problem that I would like you to do with this one will be from lesson 40, problem set 40, number 11. Problem set 40, number 11. Now we're going to move on, and we're going to look at our reciprocal trig functions, which we learned in lesson 41. What I'm going to do is I'm going to go through the example on page 293. And that example is the secant of 330 plus the cotangent of 480. So I know that secant is the inverse of cosine. So instead of adjacent over hypotenuse, I have hypotenuse over adjacent. For cosecant, that's actually the inverse of sine. So I would have hypotenuse over opposite. And then for cotangent, that's the inverse of tangent, so that would be adjacent over opposite. So those are the ratios you need to know. But now if I look at these degrees, now 330, that's below 360, but 480 is greater than 360. So I'm going to take off one full rotation, which would give me 120 degrees. So looking at this 330 degrees is going to end up in quadrant 4. And that's a 30-degree angle because 360 minus 330 is 30 degrees, which means that my adjacent is going to be root 3, my opposite will be -1, and my hypotenuse is 2. Now my second one is 120 degrees. I know that that falls between 90 and 180, and this distance right here would be 180 minus 120, which is 60 degrees. So my adjacent's going to be -1 because it comes to the left of the origin. My opposite is going to be square root of 3, and my hypotenuse is going to be 2. Now I go back to my chart. So secant is hypotenuse over adjacent. So my hypotenuse is 2, my adjacent is root 3. So this is going to be 2 over the square root of 3. But remember that you can't leave the square root of 3 in the denominator, so I'm going to multiply top and bottom by root 3.